All right, welcome everybody. Let's do this. So lesson 25, adding and subtracting rational expressions. This is Mr. G. Let's do this. So we're on page S.124, and before we actually go through this lesson, let's just have a little warm up. So with your notes, let's have this. We're adding and subtracting rational expressions. So let's look at the first problem. If we have 4 over 7 plus 2 over 7, we have the same denominators, so what do? We just add the top, so 4 plus 2 is 6 over 7. Here, the denominators are still the same, so we just have 5 minus 1, and that is, hold on, let me fix the camera angle a little bit. That's much better. Okay, so this is 4 over 10, and if you were to simplify this, try and pause the video and simplify this fraction, it should be 2 over 5, okay? But what happens when we don't have the same denominator, right? Here, we can't just say that this is 4 over 13 or something. That's completely wrong. What do we need to do? We need to make this 3 over 5 equal to some fraction, and this 1 over 8 has to equal another fraction. But you see, the thing is, we want to find that common denominator, right? That they both share, the 5 and the 8. So what are the multiples of 5? It's 5, 10, 15, 20, 25, 30, 35, 40, and if we look at 8, we have 8, 16, 24, 32, and 40. Here, 40 is the least common multiple, right? So the least common multiple that they both share. So if I know that this is 40 and this is 40, the question you need to ask yourself is, what number times 5 gives you 40? And that, pause the video and think about it, that's 8. So 5 times 8 is 40. So whatever I do to the bottom, I do to the top. So 3 times 8 is 24. Here, 8 times what number is 40? It's 5. So 8 times 5 is 40. And then whatever I do to the bottom, I do to the top. So 1 times 5 is 5. And notice that this 3 over 5 is equal to 24 over 40. So then I could say 24 over 40 plus 5 over 40, and we have 29 over 40. And that's our answer. So 3 over 5 plus 1 over 8 is equal to 29 over 40. The game that we want to play is we want to get the denominators to be the same. Okay? Let's move on. Here, take a second and write this down in your notes, but you are allowed to multiply the top and the bottom of any rational expression as long as it's the same value. So what does that mean? For example, what I want you to do is try and do this question by yourself. Right? Pause the video and try and do this question by yourself. If you want to see how it's done, here it should be the common denominator is 24. Right? So 8 times what number is 24? It's 3. And so I'm going to multiply the top and the bottom by 3. So 8 times 3 is 24, so 5 times 3 is 15. Here, what's the common denominator? How do I go from 6 to 24? This is times 4, so the top is times 4. So this is 4 over 24. And this becomes 19 over 24, right? And this is what I meant by this strategy here. You're allowed to multiply the top and the bottom of any rational expression as long as it's the same value. You see here, for this 5 over 8, I multiplied the top and the bottom by 3. You're allowed to do that, and why are you allowed to do this? 3 over 3 is equal to 1. So 1 times any value gives you, 1 times any fraction gives you the same value. Here, 5 over 8 is equal to 15 over 24. But why do we want this 5 over 8 to look like 15 over 24 so that these two fractions have the same denominator? And that's the game we're going to play. Here, let's take a look at this. If I have 3 over 2x minus x over 2x squared, how do I get it so that the denominators are the same? So what I want you to do is pause the video and try and think to yourself, how do I get the denominators to be the same? And now if you want to see how it's done, notice that 2x is equal to 2 times x, and this 2x squared is equal to 2 times x. So you see here, what this is missing, this just needs an x. Because if I multiply an x to this, then this whole thing just becomes, this becomes 2x squared minus, and this still stays the same. This 2x, this x over 2x squared still stays the same, right? But now, what did we accomplish by multiplying an x over here? This is a 2x squared. So now the denominators are the same, so we can combine it. And whatever I do to the bottom, I do to the top. So the top has to be 3x. And notice, this is what we get. Now here, how do I combine these two fractions? Let's just look at this example real quick. Actually, here, let me zoom in a little bit this way. Okay, here, if I have 4 over 7 plus 2 over 7, that's equal to 4 plus 2 over 7. Notice how we had two fractions and now we have one. So here, this is the same idea, that I'm just, because these are the same denominators, this is 2x squared, and now we can combine these two, so this is just 3x minus x. And then what is, can we simplify further, is the question you need to ask. And you know, if I'm going too fast, take your time, pause the video, and try and answer the questions I'm asking you. But 3x minus x is just 2x over 2x squared. And the question is, can I simplify this further? And yes, you can, because here, the 2's can cancel out, so I'm left with x over x squared. But remember, x is equal to x, and x squared is equal to x times x. So here, I have this. And here, the x's cancel out. So I'm just left with 1 over x. All right? And, oh, what? Very sorry here. Let me move the camera angle. I'm sorry about that. Try and rewind, but this is the idea. Okay, let's look at this one here. How can I get it so that the denominators are the same? And remember, this is an A, not an I. All right, try and pause the video and try and combine these three fractions. If you want to see how it's done, here, there's an M here. But what is this M missing? It's missing a 3 and it's missing a B. So I'm going to multiply 3b to this one, and then I have to multiply 3b to this one up here. What is this missing? This is just missing a b. So I'm going to multiply b and b to the top of this one. And what is this missing? This is missing a 3m. So 3m. And notice, why am I allowed to do this? Remember, 3b divided by 3b is 1. So 1 times this, it gives you the same value. So here, what do I have? This is 21b over 3bm plus ab over 3bm minus 12m over 3bm. And notice that all the denominators have a 3bm, so we can put everything together. So then this just becomes 3bm on the bottom, and this is 21b plus ab minus 12m. And then you should ask yourself, can I simplify further? And you can't, okay? But then this is what it will combine to. So what I want you to do is, as a class or by yourself or whatever you want, try and go through this lesson, right? Try and do 1, 2, 3, 4, A and B. When we get to C, when we get to this question, we'll do it together. But I'll try and do that in another video. But go through these questions and then, yeah, we'll be done. Okay, I'll see you in class.